So I could either find an inverse by graphing and reflecting over the line y equals x, or I can find the inverse algebraically. So the first step, if I'm going to find it algebraically, is to switch my x and y values, because that's the definition of the inverse, that I flip the x and y values. So then I'm going to solve for y, noting here that for one x value, I'm going to get two different y values. Also noting that my domain is restricted, and I can only have x values that are greater than or equal to 1. All right, so here's my inverse. It is not a function, so I'm not going to label it f inverse. So I'll graph x squared plus 1, so that's just a parabola up 1. 2, 1, 2, 3, 4. If I invert this, so here's my f of x. If I reflect it over my line y equals x, and so on, this point is going to come over to here, over 1 up 1, to, let's see, I'm going to have 2, 1, 2, 3, 4, and then reflecting. So this is the same as square root of x minus 1. This branch is the same as the square root of x minus 1. We can see it's not a function. I can see it's not a function either from my equation or from my graph. So for 1x, there are 2 y values for x greater than 1. So when x is equal to 1, I have only one y value, but for every other x greater than 1, I've got 2 y values. But if I restrict my domain of f of x to be x greater than 0, that means in my inverse, I'll only have this branch, and then that would be a function. So if we say that the new domain is x greater than or equal to 0, then this leads to f inverse of x becoming just the positive square root of x minus 1. I could have also said x less than or equal to 0, which would have led to my f inverse being the negative branch.